All right. By the way, I have uploaded all of the lectures to YouTube. I have not put links to them in Canvas. If anyone would like me to do that, please just shoot me an email and let me know. Or you could tell me now, that's fine too. But I just partly haven't gotten around to it, but partly feels like there's already a lot going on in Canvas. So, but if anyone feels like that would be helpful, that would be fine. I just don't really know from your perspective if it's just as easy to go straight to the YouTube page and get it that way. Okay, so this is a Python program that plays tic-tac-toe, and we're not going to really care about any of this except just you need to know that there's this function here called initBoard that sets it up so that the board has the numbers 0 through 9 in it, and also with an X in the middle square. And then there's also a function called displayBoard that is going to, let's see, is that next? Yeah, that is just going to print out the board. All right, so you don't need to know any of the details of those two functions for what we're going to talk about. I just want to point out that inside initBoard, we make a bunch of changes to the board, obviously, right? We're appending stuff to it, and we're assigning a value to it, to one of the cells and things like that. And then back here in main, when we call displayBoard, well, I mean, when we call initBoard, all of those changes that we make inside the initBoard function actually change this variable called board back here in main, right? So these are two separate functions. Turns out that these variables named board, I'm not actually, I'm going to retract that what I was about to say, but the changes that I make to the variable board inside this function affect this variable out here in main. And we'll see that because when we call displayBoard, it'll actually display the board with the numbers in it and the X in the middle, right? So everyone okay with that? I mean, if I need to just let you stare at this for a minute or talk about it some more, please let me know, because none of this is going to make sense if you're not tracking with that. And you can ignore all the rest of this stuff. I'm just looking at basically these 3 lines of code right here. So let me just run that so we can see it. Right, so there's our board. So I'm just proving to you that these changes inside the initBoard function, when we changed this variable named board, they were reflected out here in the main function. Okay, so I want to do that same thing now. I'm just going to kind of put some random changes in here that don't have anything to do with tic-tac-toe, but I'm just going to start a new variable named I. I'm going to assign it to 7. And then I'm going to pass it down to initBoard. And then I'm going to print it. Okay, and then down here in initBoard, I need to add that second parameter. And at the bottom of initBoard, I'm just going to say I gets 42. All right, so someone tell me, when I print I here, what's going to get printed? Maybe everyone should give me an answer in chat. All right, so far 4 votes for 7. The rest of you, not sure, don't want to say, not really there. Okay, wow, everyone thinks 7. What's that? Peer pressure? Okay, well, so that's good. Maybe 42 after passing through a net board. All right, the 7 is the correct answer. Let's just make sure. Oh, I have to cancel the old one. Restart. Okay, and there's my 7. I don't know how well you can see that, but it does turn out that what got printed was 7. Right, that's correct, Joe. But anybody want to either in chat or out loud explain more about what's going on there? Why is it that board gets changed, or the board's changes are reflected out here in main, but the changes we make to I are not reflected back in main? And Joe says, because I is not passed as reference. That's correct. I guess I'm looking for more details about that. No, print is being called after init board. Right. That's actually pretty much, I want to make clear that's not the reason. That makes sense? The part about when we call. All right, well, so I'm kind of, it sounds like you probably get this, but no one's being super excited about explaining it, so I'll just kind of plow forward here. I is not being returned that's a true statement. So I would say it this way. This variable here, board, in Python, it actually turns out to be a reference to the variable, right? We give a temporary copy of I to the init board function unless we don't change I in the main function. That's good. That's a good explanation. That's 100% correct. And then the difference is with board, what we're passing is a reference, right? So everything we do in init board is actually going to be changed. So let me try that again. This variable board down here in the init board function is a reference to the exact same memory location that this variable up here in board is referring to. The interesting thing about Python is that you have no choice in the matter, right? No matter what I do, changes I make to board are going to be reflected back in main, and the changes I make to I are not going to be reflected back in main. Everyone agree with that? Anybody, or let me ask that a different way. Anyone not sure that's the case, or not sure what I mean? Right, so no matter what I do, I can't like wave my magic wand and make it so that the changes I make to I here in init board actually do affect things back in main. I can't make that happen. No matter what I do, changes I make here to I, sorry, it's not quite fitting on the screen. Changes I make here to I are not going to change the fact that 7 is getting printed back here. No matter what I do, I can't change the fact that the changes I make to board here are going to affect board back up in main. It's just the way things are. When you have an object like board, what gets passed is a reference. When you have a primitive type like I, what gets passed is a copy of I. Okay, so Just a little background there. I'm not sure if that will have been worth the 10 minutes or so we spent on it. But I just wanted to put that out there so that for those of you who really do get this in Python, you'll see how it's related to the same ideas in C++. But in C++, we're going to find that we always get to choose, right? We choose whether what's getting passed is a copy or whether what's getting passed is a reference. All right, so let's go back to our Drawbox program that we were working on last time. And I just realized I probably should have set this up a little bit before lecture. So let me just, I'm going to pause just for a second. Okay, so here's the Drawbox program that we had last time. Anybody want to stare at that for a minute before we just plow ahead or ask me any questions about it? Let me ask this. So far we haven't actually changed any of our parameters, so there's no way for us to know whether in C++ we're passing references or whether we're passing copies, or whether we're, sometimes instead of saying copies, we use the word values. Are we passing a value or are we passing a reference? And so far we have no way of knowing that because we haven't actually changed any of these parameters inside the functions. So here's what we're going to do next. All right, so let me before I dive in, I'm just going to say, even if you didn't understand anything else so far in lecture today, you can like dive in now and you'll be fine. I was just kind of trying to set some things up for you. All right. What I want to do now is I want to organize my program a little better. Okay. I noticed that my main function has, it has some cout, cin statements in it. That's kind of detail-y for a main function, a little bit long maybe. And I also noticed that here I have 4 statements that sort of do one job, which is getting the input. And then I have 3 statements here, which do sort of another task, which is print the box, right? So I'm going to go ahead and try to reorganize this a little bit. And I'm going to say get dimensions. Okay, and so that's going to be these 4 lines. I'll move those. I'm going to take these 4 lines out and create a function named get dimensions for them. And then the next statement is going to be draw box. And I'm going to take these 3 statements out and create a function, put them in a function named draw box. Just leaving the argument list empty for now because we're going to fill those in a minute, right? So, all right, here we go. Let me create a function named get dimensions. These 4 statements go in there. And then I'm going to create another function named draw box. And these 3 statements are going to go in there. And then take them out of here. Okay, and so now other than getting the parameters and the arguments set up, hopefully this makes sense what I've done, right? Just get the dimensions first, then draw the box. All right, so draw box, I see I've got a width and a height in here. So I'm going to just say int width, int height. So that means from main, I'm going to have to send width and height. And then it looks like I've got pretty much the same thing going on here in get dimensions, int width, int height. And here, I'm sorry, yeah, and here I'm going to be sending width and height. Okay. So here's the issue, right? What is happening here, and this is this is a critical sentence from the first 4 weeks of the semester, probably, right? If you had to pick one sentence from the first 4 weeks of the semester to make sure you get here it is, okay? When I call Drawbox, this calling function is sending information to the called function, right? So in other words, what I want there is I want to pass a copy of the width and a copy of the height, or I want to pass the value, is what we say. I want to pass a value, okay? In this situation, what I want to have happen here is that I want getDimensions to be passing information back up to the function that called it. All right, so hopefully you can see that the information is going in the opposite direction there, right? To put that another way, in Drawbox, I don't need main to know about any changes I'm making to the parameters. In getDimensions, it's required that main knows about any changes that I'm making to the width and the height. The way I have it right now, that's not happening. And just to sort of see what happens if I do that, if I try to compile this, oh, what did I forget? I forgot the prototypes. Let's take care of that. Okay, compile's fine, no problem, right? Let's see what happens when we run it. Enter width 5, enter height 7. What's going on here? Someone want to tell me? What I have here is a loop that just keeps going and going and going and going, right? I just hit Control-C to get out of the loop, and now I'm back in my command line. Anybody want to, your width and height are never changed, that is correct. But how does that explain why the loop just keeps going and going and going? I will tell you. Width and height, when I first declare them, what are their values? I think we've mentioned this a couple times now. In C++, when you first declare a variable, what's in there is just garbage, right? Whatever happened to be sitting there in that memory location in the computer before we decided to call that memory location width, it just stays there, right? So probably what's going on here is I had some very large positive value sitting there in the garbage, and the loop is just going to keep going, you know, probably some, you know, a million times or whatever that value is. Make sense? So what we want is we want to be able to say, okay, this variable here in main named width, any changes that I make inside getDimensions to that variable, I want that change to be reflected back out here in this variable named width. Okay. Do we need to prime it? That is, I'm glad you asked that, and the answer to that is an emphatic no, right? This isn't about priming it. If I were to prime it, that would just mean that when I draw the box, what would get printed would be whatever values that I primed it to, right? And you're using the word prime. I would probably use the word initialize. I'm not sure if that's what you mean or if you mean something different, but I think I'm assuming that's what you mean. But, you know, I could initialize width to, you know, 5 and height to 13. And then no matter what I entered for the width and the height, I would get a box of size 5 by 13. That's not what we want either, right? what I want to do is I want to say, use when in this case, I want width and height to pass references, not values. I'm saying it. I'm saying that specifically using the words we were using when we were talking about Python, right? So the way we do that in C++ is put an ampersand here between the type and the name of the parameter. Let me go ahead and do that also in the prototype. Okay, so just to prove to you that that actually does what I'm saying it does, I didn't change anything else, right? All I changed was I just added 4 ampersands in my code. Integer width 5, integer height 7. There's my box. Okay, so I'm kind of, this is one of those things I'm beating to death, right? Because it seems to be one of those things that students have some trouble grasping. But what we're talking about here is we have two options for how we pass parameters. We can use pass by value, or we can use pass by reference. If we use pass by value, then what gets passed is a copy, right? So I've got a variable, and let me just stop there because I'm actually going to show you this in excruciating detail in a minute. So let me stop there and just say, anybody want to ask a question about that? Anybody want to say, that's still really fuzzy, I hope we talk about it some more? Anybody want to say, that's easy, let's move on? No questions? Okay, we are I'm gonna sort of keep beating this to death for a while probably, but what I want to do next is I want to show you in excruciating detail what's going on behind the scenes in each of those 2 cases. Okay, and so in the lessons, what you're going to see is I have one section of a lesson where I just kind of explain the difference between pass by value and pass by reference in 7 different ways, sort of with the idea that, you know, hopefully if I just keep saying it enough different ways, eventually it'll stick. So I'm going to let you go ahead and read that. And then in the lesson 7, I actually have a link to 6 programs that I call trace programs. The point there being, I set up some programs where the difference between how pass by value works and how pass by reference works can be really confusing. So sort of doing my best to confuse you so that you can work it out. And if you work it out, then you know, yeah, now I really get pass by value and pass by reference. So I would strongly encourage you to work your way through those trace problems at some point. So what I'm talking about here is, so lesson 7.1 is where I talk about many ways to explain pass by value versus pass by reference. Okay, and then lesson 7.2, details, implementation details, details about how it works and trace problems. Okay, and then you may remember that lesson 7.3 is completely sort of a digression about generation of random numbers. So that's lesson 7. Okay, I think, and this is a little bit of an experiment, but I think I'm going to try to explain or demonstrate in detail about how pass by reference and pass by value work by, oops, I didn't want to do that. Using an Excel spreadsheet. I've done this before and it seemed to work pretty well. It doesn't turn out to be like too much hassle, but all right. So basically, I'm using the Excel spreadsheet to represent the computer's memory. Okay. So every time we declare a variable over here, I'm going to set aside or allocate one of these cells to represent the value being stored in that variable. So, and I'm basically going to pretend I'm the computer here. I'm going to go line by line through my computer and trace exactly what's happening. This is a super important skill. You probably know by now, right? If you write your program, everything looks fine to you, you run it, and you don't get the expected results, then probably what you're going to want to do is exactly what I'm going to do right now. So here we go. Starting here, the first line I see is int main. I'm sorry, int width. So I'm going to create a variable over here. Maybe I'll try putting a box around it and see if okay, so here I'm going to say that this is main's variable named width. Okay. All right. And what's in here when I first declare width? No one knows, right? I'm going to call that junk. I'll just say it's junk. All right, and then now I'm going down to the next line here. I'm declaring a variable named height. So here I'm going to have main's height, and starts off with junk. Okay. All right, next statement. Call the function getDimensions. So we're down here. Every time I call a function, the first thing that happens is I allocate any memory for the parameters. So here is getDimensions width. Making this wider. What am I doing wrong? Okay, we go. And okay, so here the question is, what is going to be stored in getDimensions width? Well, because we have that ampersand there, what that means is what's going to be stored in getDimensions width is a reference back to the corresponding argument. And the corresponding argument was main's width, right? So to be very literal here, just for a minute, what's being stored in getDimensions width is a memory address. That's what a reference is in the end, a memory address. So I could say, for example, maybe 4A7F. Okay, that would be a memory address. And that's the memory address of main's width. So I could say maybe, okay, 4A7F is actually the memory address here. Okay, anybody want to question, comment so far? And then getDimensions height is going to be storing the memory address of main's height because that's the corresponding argument. It's the argument that corresponds to this parameter. So, you know, maybe 4A83 or something. Okay, now, assuming everyone is following this, what I'm going to say next is when computer scientists draw diagrams like this, which we do a lot, it doesn't really work very well to actually try to put the memory location in there. So what we do is, instead of trying to actually put the memory location of mains width in this box, we're going to just draw an arrow back to mains width. Okay, and here I've done this before and it's worked pretty well. There's a way. How do I draw pictures? Insert, that's what it is. Insert pictures, shapes, one arrow. Sorry, give me a second. I think this will be worth it in the. Okay, so I'm gonna get rid. Bummer. Okay, there's my arrow. I'm going to get rid of the memory addresses here. And instead, I'm going to make, I guess I have to go back and do the picture. Once I get this going, I can just copy and paste the arrows and it looks fine. Okay, just a second ago, this all right, so here's get dimensions width, and what we're going to say is that what's being stored in get dimensions width is an arrow back to mains width. Okay. Is it important for us to know what a memory address is? Oh, well, sure. Let's talk about that for a second. Your computer's memory is made up of memory locations where data is stored. And every, wait, actually, I think I may be misunderstanding your question, but let me finish anyway. Every one of those memory locations has an address so that the computer programs can specify which memory location they mean. I think your question may have been more along the lines is, as a programmer, do I need to know the memory address of that memory location? And the answer to that is no. In fact, we don't want to know that, right? And in fact, it will be different every time. It may be different every time you run the program. Did I answer your question? I gave the answer to two completely different questions. Okay. All right. So sorry that took me a while to get going, but I think that should make sense now, and I think that we'll be able to do better. It won't take as long next time. But so the question is, does everyone understand what that arrow is doing now? That is the way we represent in a picture the fact that what get dimensions width is storing is the memory address of mains width. All right. And then we've got the same thing with get dimensions height. What get dimensions height is storing is the memory address of mains height. And so I draw an arrow like that. Okay. This is super, super common in computer programming. You're going to see lots of pictures with boxes representing memory locations and arrows pointing back and forth between the different boxes. So this is a good thing to spend a little time on. Any questions? So far where we are, we're tracing through our program, and we called get dimensions. We set up the parameters in get dimensions. So now we are ready to start executing the statements inside get dimensions. So we say enter width, the user enters width. Let's say the user enters 7 for the width. Normally, if width was a normal variable, we would put the 7 right here in get dimensions width, right? But get dimensions width is not a normal variable, it's a reference. So instead of putting the 7 there, we follow the arrow and then we put the 7 where the arrow is pointing. Okay? Everyone following? And now we are on line 26. Into the height, the user enters 13, for example, for the height. We go to put the 13 here, we see, oh, that's not a normal variable, that's a reference variable. So instead of putting the 13 here at get dimensions height, I'm going to follow the arrow and put the 13 back here at mains height. Okay, now I'm done with get dimensions. So I go back up to main, and I'm gonna, the next thing that's gonna happen is I'm gonna call draw box, but I just wanna say, it's important to understand that when I finish executing the get dimensions function, what happens to these memory locations? The answer is they go away. Or I guess to be really precise, what happens is they are deallocated. In other words, they're no longer get dimensions width, they're no longer being used for anything. The computer is free now to just use them for something else later on. Okay. The way we would normally picture that is we would just make them go away. So I'll just like clear contents easily enough. Sure. Okay, so now those are gone. The arrows are gone. I'm just going to put them over here so I can use them later if I need to. And now we're back to this picture. Okay, so this is a good way of visualizing what was accomplished when I called get dimensions, right? I called get dimensions. Before I called get dimensions, these two variables had garbage in them. Now that I'm done calling get dimensions, they have values in them. Now I'm going to call draw box. And so just to pause and make an observation, basically what we just did was the hard part, right? We just did the only pass by reference that we're using in this program. Now we're going to be using just plain old pass by value. Yes, that's correct. Get dimensions width is itself a memory location that has been allocated. And what it is storing is the address of another memory location. Exactly. Well put. Or was, I guess we should say, since it's gone now. But okay, so we're about to start executing the draw box function now. Before we start executing the statements inside draw box, we're going to set up the width and height variables. So here is draw boxes width. And here is draw boxes height. Okay, and so here's how pass by value goes. The corresponding argument for draw boxes width was this width right here, which is mains width. And so what we do is we look up, when we call draw box, we look up what's being stored in width, well, 7. And so when we call draw box, we're sending 7. And so 7 gets put into the corresponding parameter here. Okay, so that's pass by value. What we're doing is instead of putting a memory location there, we are actually putting a copy of the value that main passed. Okay, same with width. I'm sorry, same with height. Draw box's height is going to be 13. Okay, and then if we keep going, we would, draw horizontal line, draw vertical line, draw horizontal line. We'd pass those values on down, and eventually we'll get a box that's 7 by 13. And then when we're done with draw box, all of this stuff goes away again. and we're back up here in main. We just finished executing the drawbox function, and the program's going to end. Then we're done. Anybody want to ask any questions about that process? I will say that you can probably get by okay for a while without understanding things in that much detail. One of the reasons I actually go into that much detail is I think for many students it actually helps understand the difference between pass by value and pass by reference to see what's going on behind the scenes. But there are also some cases, and you'll see some of this in the trace examples from the lesson. There are some cases where you really do need to understand in this much detail what's going on behind the scenes so you can figure out what's going on in your code. All right. If there are no questions about that, I am ready to change gears and talk about something else. Bringing up the next. Whoops. Second here. Okay. All right, I think I'm done with this. Let's get rid of it. This example. So when we were talking about random number generation, one of the lines of code we saw was something like this. I guess to clarify, we didn't actually talk about that, but I know that you have done that because you had to do that for assignment 2, right? So, excuse me, something like num1 gets rand modulus 101. Oops. Okay, the reason I'm putting this down here is I want to make an observation about this function call, right? This function call is different from any of the function calls that we have seen so far in our study of functions, right? In our study of functions, we've seen things like draw box, dimensions, right? But the thing that all of our function calls have had in common is that they have been on a line by themselves with a semicolon at the end, right? In other words, we called them as if they were statements, right? Is that clear? Like if another statement would be x gets y times 3, right? On a line by itself with a semicolon at the end. This one here, we're not calling it as if it was a statement. We're calling it, we are using it in the place of where we would normally use an expression, right? So, and what we are expecting is that some integer value is going to replace that expression. So what I'm getting at is the difference between a void function and a value returning function, okay? We have only talked about how to write programmer defined void functions. We have not talked about how to write a function that you could use in the place of an expression like this one. Okay. So the topic that I'm starting now is the topic of value returning functions. Let me just point out before I do that most students don't have any trouble at all with understanding how to write a programmer-defined value returning function instead of a programmer-defined void function. Most of the confusion comes with how to call them. So let's use, I just want to do a quick example here. Actually, I'm a little short on time, so I'm not going to do that example I just mentioned. And I'm assuming that most of you probably have this from Python. I'm trying to remember. In Python, in Python, basically, you can use a function either as a void function or a value returning function, and you don't have to specify the difference. You know, in Python, right? Some functions, sorry, I'm stretching my brain a little bit here. Correct me if I'm wrong, but some functions return values and some don't. So display board does not return a value. There's no return statement in it. Make list of free fields does return a value. Return valid moves. I know you didn't study this. I'm just showing you that the syntax is exactly the same between functions that do return values and functions that don't return values. The only difference is you just return a value sometimes. And then here's an example of one where what the value that's being returned is always going to be either true or false. In C++, the main difference is you have to specify that when you are creating the function. So I'm just going to do an example of a value returning function. We're going to write a function named power. It's going to return an integer. It's going to take two arguments, a base and an exponent, and it's going to return the answer. So when you're defining a programmer-defined value returning function, there are two things that you have to do differently compared to what you did for a void function. The first difference is the very first word you type. Instead of typing the word void, you're going to type the type of value that the function is going to return. So I mentioned that my power function is going to return an int. So the very first word I type is int instead of void. Then the name of the function. And then everything else is going to be exactly the same as if I was defining a void function. Let's say double base int power. Okay, and then I'm going to have some statements in here to calculate what the answer is. And then at the bottom, here's difference number 2 between a void function and a value returning function. Difference number 2 is I got to have a return statement somewhere in my function. So at the bottom, let's say, I'm going to say int answer. And then at the bottom somewhere, I'm going to say return answer. Okay. All right, if you were all taking programming for the first time, I would take a few minutes and work through this, but instead I'm just going to go ahead and write the function definition for this. That's interesting. I'm going to start off answer at 1, and then I'm going to have a for loop that goes through power times. And each time through the loop, I'm going to multiply the answer times the base. Okay, so when I'm done doing that, basically multiplying answer by itself, power times, putting it in informal English language anyway. And then when I'm done with that, I'm returning the answer. Okay, so there's my our first C++ value returning function. Let's go ahead and put this in a program and test it, because as I said, often the confusing part for students is calling these value returning functions. So I could say, let's say, let's do a one-liner here, power 2, 8. Anybody know what that is? So I can't resist my little speech about this. Big number, yeah. In computer science, I think one of the most important things that you can do to make your life easier is learn how to work with powers of 2 quickly and easily. It's going to help you out a lot later on down the road. And so what I do is I know what 2 to the 10th is. I just have that memorized. 2 to the 10th is 1024. So 2 to the 8th is easy to figure out, right? If I know that 2 to the 10th is 1024, in order to get 2 to the 8th, I just have to divide by 2 twice. So 1024 divided by 2 is 512. 512 divided by 2 is 256. So this is 256. All right, just end of fun digression. So if I save this and execute it, or I guess compile it, oops, forgot. You know, you guys may have noticed that I forget this every single time, right? I have to make the prototype. And there's my 256. Okay. Oh, great question. Why would we use this instead of just using a void function? Basically, number one, you never have to. You could always get by with just using a void function. It just turns out that often it makes your code simpler, easier to understand. Okay. So for example, in this case, if we had made power a void function, what would we have to do? Well, we'd have to have a third argument here. We'd have to use pass by reference. And then up here, we'd have to declare a variable named, let me just call it result, so it's something different. And then we'd have to call power, we'd have to say call power with a 2 and an 8 and a result. And then we'd have to say cout result. Okay, and then we would get rid of this return statement. Right, and so I think I have equivalent code here. I think it's going to be this. It's going to do the same thing. Maybe we should just double check. Oh, except I have to change. Let's see if just changing the prototype is all that needed to happen. I'm thinking there's probably something else. What did I do? Oh, oh no, I just didn't want to declare it because it's already there. Let's try that. Okay, so long answer, but bottom line is, look at what we had to do here. We had to do this kind of clumsy 3 statements, requiring a whole new variable, whereas before what we had was just one nice clean line of code. Okay, so I would say well, here, whoops, that's not what I meant. Okay. So your question is actually also interesting because this is something that programmers have to decide. And it turns out that sometimes programmers, there are situations where maybe some programmers might use a void function. Some programmers might prefer a value returning function. One way to think of value returning functions is they are functions that you use when what you want is really exactly like a function that you would see in an algebra class, right? Like f of x gets, it just returns a value. You could say that, you could say that here f of x, power of x comma y could be a very similar to an actual function that you would see in algebra, whereas a void function is a function that actually performs tasks like input and output and things like that. So one way, so I'm not just answering the question because this was actually the next topic. Anyway, the question of when do I use a value returning function? When do I use a void function? One way to think about that is, try both out, see which one makes your code more clear. My suggestion would be, I always just use a void function unless I have a situation where there's nothing going on inside the function except that I'm just taking the parameters and doing some sort of calculation and returning the result. Otherwise, I use a void function. All right, anybody want to ask a question about that? Okay, we have a few minutes left. I want to just do one more value returning function example. Let me just, before I go there, let me just encourage you to at least read through lesson 8, because that's basically what I'm working on right here. But I'm skipping some details, and I talk a little bit more in there about how to choose when to use which, and it might help. So I think you can probably read it fairly painlessly and quickly, and you might get a lot out of it. All right. So there's some value returning functions return a value of type bool. And those are sort of special cases, not syntactically or anything, but just conceptually. The way they get used is often as a condition in an if statement or a while loop. So let me just go ahead and do an example. I want to write a function that determines whether the current year, or that determines whether the parameter is a leap year or not. So this is going to return a bool, either true or false, right? True if it's a leap year, false if it's not. So one thing I want to point out is that often, and I might even venture to say usually, in the case of a bool value returning function, starting the function name with the word is good practice. It makes sense, right? Because in my code, I might say something like, if is leap year 2000. And so naming the function with something that starts with is, I think helps that to read more like It's an English, a logical English sentence. It's just sort of a signal to the reader to know that this is something that's going to return either true or false. Okay, so not sure how many of you know the details of how to tell whether a year is a leap year or not. Typically, if I do this in a classroom and I ask students, about 3/4 of the class thinks that if the year is divisible by 4, then it's a leap year. Turns out that's not exactly true. For example, the year 1900 was not a leap year, even though it's divisible by 4. And so the rule goes something like this. If a year is divisible by 4, then it is a leap year, except if it's divisible by 100, then it is not a leap year, right? Except the year 2000, as it turns out, was a leap year, right? So we have another except if it's divisible by 400, then it is a leap year. Okay, so that's the actual rule. We're actually going to see this is leap year function again. So let me just show you how I would write this. This can actually be one of those functions where if you start it from the wrong side, it can get very complicated very fast. Okay, if I start with the general case and say, okay, if it's divisible by 4, I'm going to say it's a leap year, but then I have to throw in a but because it might be divisible by 100. That's complicated. The simplest way to write this is actually to start with the big numbers, right? Start with something where I can instantly and simply take care of some of the special cases. So I'm going to say if year is divisible by 400, then I can immediately say for sure that it is a leap year. All right? Any questions about that? So now I can move forward with the rest of the function and I can forget about the possibility that the year is divisible by 400 because I've already handled those cases. So now I can easily and simply say that if year is divisible by 100, then it is not a leap year. Everyone okay? All right. I'm going to just continue this pattern. Now I can definitely say, I mean, at this point in my code, I know that year is not divisible by 400 and not divisible by 100 because I've already checked for those cases and returned a result in those cases. So now I can say, yeah, if year is divisible by 4, then it is a leap year. Okay, and then after that, I can say, well, at this point, I know that the year is not even divisible by 4 at all, so I know I don't even have to think about it. It's not a leap year. Okay, so I'm actually going to leave testing this. Well, no, I should probably show you. Let's say see out, enter a year, CN, oops, year, if is leap year, year, See out, leap year. Else, see out, not a leap year. Okay, not gonna forget my prototype this time. Let's try this out. We got to variable. So if I enter 2000, that was a leap year, right? Okay. If I enter 2012, that was a leap year. If I enter 1900, not a leap year. Okay. One more quick thing I want to show you here. Okay, Joe, great question. The answer is no, because I'm not going to get to this point in my function anyway if this condition is true. If this condition is true, then what I'm doing is I'm returning true, and that immediately and instantly ends the value returning function. Okay. What I am going to say, though, is that right here we have a pattern that is one of my sort of pet peeves. We can simplify that easily, and this is actually a style convention. If you want to look later, I think it's like 7p or something. This, what we're saying here is, if this condition is true, return true. I'm not sure I would say that it's common, but it's common to, I guess it's common to have a situation where you return true or false, and then you can just move on without an else because you know that the function just stopped already, if that's what you mean. But let me explain what I'm thinking about this statement right here. If this condition is true, then return true. If this condition is false, return false. So really all I'm saying here is whatever this condition is equal to, return that. So we're just going to say return year modulus, modulus 4 equals 0. And that takes the place of all of this. And as a bonus, it shows other programmers reading your code that you know what you're doing. Okay, so hopefully this last step made sense. Sorry, I'm kind of squeezing it in the last second here. You will see this in the style convention, pretty much like the very last style convention in the syllabus, if you want to go take a look and see what I mean there. Okay, we're out of time, but anyone have any last minute questions or comments? All right. Good luck in lab. I think most of you have lab tomorrow, if I'm not mistaken. Hopefully you'll get this week's assignment done. And I'll see you Monday. And I'm just going to answer Joe's question real quick. I cannot, there's nothing left in here that matches the rule in the style convention exactly, right? I have applied the rule in the style convention. I've simplified my code, but now that I'm looking at it, there's nothing that matches that pattern exactly. So there's no more, I cannot use that style convention to simplify this anymore. Yes, you could stay here for office hours, although I will be taking a break. let me just actually, you've brought up one more point. And that is that you will, like if you Google online and you ask for a C++ expression to check to see if something is a leap year or not, what you'll see is they will have combined all of this code into a single line that just says return. And then there's this big, long, complex, confusing logical expression, okay? In my opinion, that actually is more difficult to understand than spelling it out like this. So, you know, other very smart programmers might disagree with me on that. But I think that taking this very simple simplification is a good idea. Going the next step and combining all of this into one complex logical expression, I think makes it more difficult to read and understand. All right, I will let you go now. I think I'm going to actually end this meeting, and then I'll start up again at 11 for those of you who are wanting office hours. If I can remember how to do it.